Today we're talking about the disk and the washer method, and we use those to find volume. So make sure you have your notes printed out. Also make sure you print out that handout that I linked to that I call my magic notes, and I try to put little screenshots of how to use the notes in here as we go along. Okay, let's look at the first one. Find the volume of the solid generated by revolving the region bounded by the graphs of y equals the square root of x, y equals 0, and x equals 4 about the x-axis. All right, first thing we need to do is just graph it. So I'm going to graph y equals square root of x. That would be 0, 0, 1, 1, and 4, 2. So label them so you know what you're doing. Let me move that out of the way. All right, and then y equals 0. Right here, and x equals 4. So I've got this purple region right here. So first thing you want to do is draw it. Okay. All right. Now, second thing, it says decide if you are solid to the axis of rotation. All right. This says you are rotating about the x-axis. All right, so I'm rotating about that. So what I'm trying to decide is, let me mark it in yellow, is see my purple region is what I want. Is it drawn solid all the way to that x-axis? Well, yeah, there's no holes in there. That purple stretches all the way across that yellow line, all the way across that x-axis. Okay, so all the way across, and that means I'm solid. I'm going to do it back in the green because that's what I had originally labeled it as. All right, so that means I am solid to the axis of rotation. Okay, so if you're solid to the axis of rotation, that's when I use the disk method. Okay? All right, for disk and washers, you're going to draw a slice that is perpendicular to your axis of rotation. So we've looked at area and we looked at slices before. A slice is just going to be a small little rectangle, and you're going to draw it perpendicular to your axis of rotation. So I'm going to draw that. Whichever axis I'm hitting the x-axis. That tells me if I'm a dx or dy. So if I hit the x-axis, then I'm a dx. Okay? All right. So then, step 3 says you're going to pick your formula. We picked it. It is disk. All right? So it's going to be pi, and it's going to be integral from a to b, the radius squared times the dummy variable. All right. We did step 4 already. We drew our slice, and we determined that the dummy variable was going to be a dx. So that's a dx. All right. Get a and b off that axis now. So go back and look at your picture. All right. Your dx, so you're going to get a and b off the x-axis. We're going to look at where you start. Keep trying to move that cursor. All right. From here to here. You can see those 2 points. I'm going from here to here. So I'm going from 0 to 4. Okay. All right. And then look right here. It says if you spin about the x or y axis, which we're doing, we're spinning about the x, then you apply the following. For a disk, the radius will be the graph. Okay. Well, the graph that we have was the square root of x. Okay. So that's my graph. You want to make sure that it matches the dummy variable. So you want to put x's in. If it was a dy, you would have to solve that for y and square both sides to get rid of that square root. Okay, so this is what I'm going to work on to get the volume. So pi times the integral from 0 to 4. When you square the square root of x, you just get x dx. So this is a pretty easy one. If I integrate it, I get 1/2 x squared, and I'm going from 0 to 4, and then I'm going to multiply all that by pi at the end. So I won't work all of these fully out because at this point you should know how to plug in all those values, but I'll work this first one out. So that one's just going to go away because it's just 0. So when I square 4, I get 16, and half of it would be 8. So this one gives me 8 pi as my final answer. Okay. Make sure you're memorizing my, the magic notes that I have linked because it'll really help you with what to do. All right, let's keep going. All right, find the volume of the solid generated by the region bounded by the graphs of, I should say, find the volume of the solid generated by rotating the regions bounded by the graphs of y equals squared x, y equals 0, and x equals 4 about the y-axis. So little part is left out of those directions. It's probably all of these because I just copied and pasted, but y'all know what I mean. All right, so I already got it graphed for you to save a little time. All right, now this time you are rotating it about the y-axis. Okay, so I need to spin about there. So we drew it, first step. Now second step, decide if I'm solid to the axis of rotation. Well, I am rotating about the y-axis, and you can see that purple region again is what I have, and I'm not solid to the y-axis. You know, there's all this space in here, okay? You're not drawn straight to it like you are to the x-axis. So when you're not drawn solid to the axis of rotation, then we're going to use a washer. We'll talk about the shell in the next section. All right, so your formula for a washer is V equals pi integral a to b big R squared minus little r squared times your dummy. Okay. All right, so again, for a washer, a disc or washer, you are going to draw a slice that is perpendicular to your axis of rotation. So I need to draw my rectangle like this to be perpendicular to this axis of rotation. You want to tee into there. All right, so if you think about what, stretching that yellow rectangle out, let me get back to my pens. All right, stretching it out, what axis would you hit? Well, you hit the y-axis, so this tells you you're a dy, okay? Whatever axis you tee into, that's what your dummy is. So fill it in. All right, so if you spin about the x or the y, then apply the following. So again, we're doing this washer one. All right. So we have our formula, and it's pi. Right? We know it's a dy, so if we look back so we can get a and b, right? Think about where your purple region, where it starts and where it stops from the y-axis. So, here to here, and you're pulling those y coordinates, so you're going from 0 to 2. Right? 0 to 2. Okay, look at what it says. I'm trying to find a highlighter, but I don't know where that is. All right, we'll just mark it right here. Okay, so look, the capital R is the top graph or the right graph. If you're look at which way our rectangle is. We've got a right minus left rectangle and not a top minus bottom. Okay, so let's fill that in. The right rectangle. All right, so the capital R is the right rectangle. Let's look at our picture. So it is, I need more colors. It's going to be this side, the right of the rectangle, which would just be 4, minus the little r. So let's see, the little r is the bottom or the left graph. All right, so now if I look at the left graph of the rectangle, all right, then it's this side. But there's a problem. If I try to stick in this, and the dummy is dy, then there's a big problem. Your dummy is dy. You can't stick in an x. You can't do that. So you got to resolve that, and you got to make sure that you're matching the variables. So you don't want to put in the square root of x. You want to solve it. If you square both sides, you get the y squared dy. Okay. So this is what I want to work out. So integral from 0 to 2, that would be 16 minus y to the 4th dy if I squared them out. All right, if you integrated it, you're going to get pi times, 16y minus 1/5 y to the 5th, and you want to evaluate that. You want to integrate it from 0 to 2. So you would, again, and I'm going to speed up some because I got a lot of these examples to get through, but you're going to plug in 2 here, and you're going to plug in 0 here, and multiply it by pi. You should be able to do that, and I got 128 over 5 pi when I did it. Okay. All right, so some more examples. Find the volume of the solid generated by revolving the region bounded by the graphs of x equal y, y equal 3, and x equals 0 about the y-axis. So I went ahead and graphed it for you, and we are rotating about the y-axis. So are you solid to that y-axis? Well, yeah, if you look at it, you're solid right there. There's no space, so you know you're a disk. All right, so my formula is pi integral from a to b radius squared times the dummy. So I am going to draw my slice for disk, all right, perpendicular to the axis of rotation. So I'm drawing my rectangle like that. And which axis did I hit? I hit the y-axis, so that's a dy. Right now, get A and B off that y-axis. So I'm going from 0 to 3. All right. And then I'm a dy, so I just need to figure out which graph I'm using when my graph is that x equals y. So I'm going to put in the y. So that's pi times the integral from 0 to 3 of y squared dy. If you tried to do, you know, right minus left, you're fine still, because you've got your graph, which is the red one, which would be that y. And if you said minus the left end, that's just 0. Y minus 0 is just y. Okay, so if you want to just do it the other way, you can. You'll be fine. So this is pi times, if you integrated that, you get 1/3 y cubed, and you're going from 0 to 3. So I'll let y'all plug that all in. But I got, when I did it, 9 pi. All right. Find the solid, find the volume of the solid generated by revolving the region bounded by the graphs of y equals 2x and y equals 4x squared about the y-axis. So I'm rotating this about the y-axis. And you can kind of see it's a really small area, but I'm just in here, okay, that little purple in there. I had a hard time figuring out, okay, where do they intersect? Okay, so remember, if you can't tell, we talked about this in area, if you can't tell where they intersect, all you have to do is set them equal. All right, so I'm going to set 2x equal to 4x squared. So if I get everybody on the same side and factor it, I can factor out a 2x. I'll see that when I set both of those equal to 0, that I get 0 and 1/2. Okay, so that's where they intersect. All right, and I'm rotating about the y-axis. Okay, so that is going to be not solid to the axis of rotation. And if I'm rotating, I got my rectangle that way. So that is a dy. All right, so I don't want to use those points, okay, because those are my x values. If you plug those into either one of them, you will get the y values. All right, so if I just plug it in here, if I plug in 0, I get 0, okay, and 0, and if I plug in 1/2, I get 1. So I know now that I'm going from 0 to 1. I remember, make sure everything matches. I was a dy, so I had to plug those into either one of the graphs to figure out what those would be. All right, not enough space here, so let me move to the next slide so we can set it up. All right, so I'm a washer. So my volume equals pi integral a to b, and it's capital R squared minus little r squared times the dummy. All right, so we already said that was going to be 0 to 1, and I'm a dy. So let's figure out, so remember, capital R is going to be your right graph, little r is going to be your left graph. So let's figure out which one is that. So the green is going to be on the right side of my rectangle, but you can't stick in 4x squared. You got to solve that. All right, so if you divided, it would be 1/4 y equals x squared, and if you square rooted it, you would get 1/2 square root of y. And you would have a plus and a minus, but if we're talking about the one on this side, we're going to do the plus value. So that one is going to be x equals, not y equals, sorry, x equals 1/2 square root of y. And I went ahead and wrote it as y to the 1/2, so it would be easy to plug in. All right, so that's going to be my right graph. So I'm going to plug in 1/2 square root of y, or 1/2 y to the 1/2. All right, and then let's look at the left end. All right, the left end is going to be the red end, and that is y equals 2x. But again, I can't stick in that. I have to solve it for x, so x equals 1/2 y is what I would plug in. All right, so that's what I've got, and if you worked it out, when you square it, you get squaring 1/2 gives me 1/4, and squaring the square root of y just gives me y, and squaring this, I get 1/4 y squared. dy. All right. If I were to integrate this one, I'm going to hold off on that pi. Think about what you're doing. If you add 1 to it, you get 2 dividing by, if you add 1 to it, you get a new power of 2, and dividing by 2, same as multiplying it by a half. And if you did this one, if you added 1 to it, you get your new power of 3, and dividing by 3 is the same as multiplying by a third. And you're going to get 1/8 y squared minus 1/12 y cubed, and you're going from 0 to 1, plug that in, multiply it by pi. I got 1 pi over 24 as my answer when I did it. And I will try to post all of the work where I actually did the math out in your notes so you can have that. And then this last one, find the volume of the solid generated by revolving the region bounded by the graphs of x plus y equal 1 and x minus y equal -1 and x equal 2 about the y-axis. So I went ahead and graphed it for you, and I went ahead and labeled it because I was like, all right, I have them both solved for y and x, so when we plug it in, it won't be that bad. All right, so I'm revolving it about the y-axis. All right, I am not solid to the axis of rotation, and there's a problem. All right, so when I'm going to use a washer, and when I look at this, if I think about it, you know, you're going to do a slice like this, because you're going to draw perpendicular to that axis of rotation. So you've got a right minus left rectangle. And is the same graph going to always be on the left side? No, it splits. You've got on the top rectangle, you've got the blue on the left, and on the bottom, you've got the red on the left. So I'm going to have to do 2 separate ones. I'm going to have to do 2 separate integrals, and it splits right there. Okay. So I'm a washer, I'm not solid to it, and I'm going to have to do 2 of them, all right? And since these are, if I extended that rectangle out, that slice out, it would be a dy. So I've got 2 rectangles. I've got, all right, pi, and I've got one of them is going to go from -1 down here, that -1 up to 1. Okay, and I'm going to have to do, figure out that. And then the other one is going to go from 1 up until this top part where that blue, where the blue and the green intersect at 3. All right, so let's figure that out. All right, so on the bottom one, all right, I'm looking at the bottom yellow rectangle, and so I've got the right minus left. Well, the right is just the 2. All right, now on the left graph, and it's the red one, and you want to get it to where you put in the y's, not the x's. So we've got -y plus 1 squared. All right, and then the 1 to 3 one, that is going to be your top yellow rectangle. So again, the right graph is still the 2, but the left graph is changed. I'm going to do that y minus 1. And we'll do the math out. My video is getting a little bit too long, so you want to square everything out. The one thing I did want to make sure you guys are careful on is when you square that, all right, when you square that, remember, you use your rules. We got to wait, hold, and distribute the negative, but square the first, multiply them and double them, square the last. If you need to write it out twice and FOIL it, that shouldn't still be there. Sorry. Do that, and then you can distribute it. And clean it up before you integrate it. So you integrate, you've got 3 and a 2y and a minus a y squared. When I did that one, I'm trying to remember, trying to find my answer where I did it so I could do it, but you're going to do both sides. Okay, you'll do the same thing here, but at the end, I got 32 pi over 3. When you integrate it, you're going to realize that you've got the exact same integral over here when you square all that out. because you're going to get y squared minus 2y plus 1. And when you distribute it all, you're going to get this. And then it simplifies to that. So it's the same integral. So what you can do, all right, let me erase that answer where I got it. So since it's the exact same thing that you are integrating, oh, didn't mean to hit the eraser. All right. It's the exact same thing that you're integrating on both of these. You can just integrate it now and plug in, and you can go from -1 to 3 of that. And then you're going to get that, or you can do them separate and add them together. It doesn't matter. It gets you the same answer either way. But 32 pi over 3. So make sure you practice these. Make sure you get them, and I will post all the math where I did them out in your class.